Welcome to Racing Through Math. Today, we'll master speed, distance, and time problems. The DST triangle is your secret weapon. D for distance at the top, S for speed and T for time at the bottom. Cover the letter you want to find. Speed equals distance divided by time. Time equals distance divided by speed. And distance equals speed times time. Remember this triangle. Here's a powerful way to think about speed. Imagine speed as a distance block, the distance an object covers every second. Let's compare a car traveling at 25 meters per second and a bus at 15 meters per second. The car's speed block is 25 meters, that's how far it travels every second. The bus's block is smaller at 15 meters. Watch what happens over 3 seconds. Each block stacks up showing the total distance covered. After 3 seconds, the car has traveled 75 meters while the bus covered only 45 meters. Faster speed means bigger blocks. Remember, speed is simply the size of your distance block per second. Bigger block, faster speed. In speed problems, there are two main types you'll encounter, meeting and catch-up. First, the meeting problem. Two objects start at opposite ends and travel towards each other. They move towards each other until they meet. Second, the catch-up problem. Both objects travel in the same direction, but one is faster. The faster one eventually catches up to the slower one. Let's start with the meeting problem. When two objects move towards each other, they meet somewhere in between. A car and a bus are 120 meters apart. The car travels at 25 meters per second, and the bus travels at 15 meters per second. They start at the same time and move towards each other. How long until they meet? Let's visualize this. The car starts on the left, and the bus starts on the right, 120 meters apart. Watch as they move towards each other. Every second, the car covers 25 meters while the bus covers 15 meters. After 3 seconds, the car traveled 75 meters and the bus traveled 45 meters. Together, they covered the full 120 meters. Here's the key insight. When two objects move towards each other, we add their speeds together. This gives us the combined speed. To find the meeting time, we divide the total distance by the combined speed. 120 meters divided by 40 meters per second equals 3 seconds. Next, the catch-up problem. When a faster object chases a slower one, the key is the speed difference. A car traveling at 25 meters per second starts 30 meters behind a bus traveling at 15 meters per second. They move in the same direction. How long until the car catches up? Let's visualize this. The bus has a 30-meter head start, and both are traveling in the same direction. Watch as they move. Every second, the car covers 25 meters while the bus covers only 15 meters. The car gains 10 meters each second. After 3 seconds, the car traveled 75 meters and the bus traveled 45 meters. The difference is exactly 30 meters, the original lead. Here's the key. The car's extra speed is 25 minus 15, which equals 10 meters per second. This is how fast the car closes the gap. To find the catch-up time, divide the lead by the extra speed. 30 meters divided by 10 meters per second equals 3 seconds. Now it's time for the Olympiad Challenge Zone. Let's tackle some competition-level problems. Here's our first Olympiad challenge, the wind factor. Joan cycles 1 kilometer in 4 minutes with the wind, and returns the same distance in 5 minutes against the wind. How long would it take her with no wind? Let's visualize the problem. The wind blows from left to right on both roads. First, Joan cycles with the wind behind her. She completes 1 kilometer in just 4 minutes. The wind helps push her forward. Now Joan returns, cycling against the wind. This time it takes 5 minutes for the same distance. The headwind slows her down. Can we just use total distance divided by total time? 2 kilometers divided by 9 minutes equals 0.222 kilometers per minute. Watch out! This is the average speed trap. This approach is wrong. Here's why. The wind helps Joan for only 4 minutes, but it works against her for 5 minutes. That's 1 extra minute of headwind. The wind hurts more than it helps because Joan spends more time fighting against it. The correct approach is to find Joan's speed in each direction. With the wind, she travels 1 kilometer in 4 minutes, so her speed is 1/4 kilometer per minute. Against the wind, 1 kilometer in 5 minutes gives 1/5 kilometer per minute. To find Joan's true speed without wind, we average the two speeds, 1/4 plus 1/5, divided by 2, equals 0.225 kilometers per minute. Finally, to find the time for 1 kilometer without wind, we divide 1 by 0.225. That gives us 4 4/9 minutes, or about 4 minutes and 27 seconds. Here's an Olympiad challenge from the Regional Math Olympiad. 2 ferries travel between islands at different speeds. They meet first at 8:30 a.m., stop for 15 minutes at their destinations, then meet again at 9:23 a.m. When did they start? Let's watch the ferries in action. They start from opposite islands at the same time. The ferries travel toward each other and meet for the first time at 8:30 a.m. They continue to their destinations, where each stops for 15 minutes. Then they head back and meet again at 9:23 a.m. Watch carefully as the ferries travel. Let's count how much distance they cover together. At the first meeting, the ferries have together covered exactly 1 river width. They continue to their destinations, completing the second width together. Then they return and meet again, covering a third width. So by the second meeting, they've traveled 3 widths total. This means from the first meeting to the second, they traveled 2 more widths. Let's trace the journey. From the first meeting at 8:30, through their destinations where they rest, to the second meeting at 9:23, that's 53 minutes total. But they rested for 15 minutes, so the actual travel time is 53 minus 15, which equals 38 minutes. And this 38 minutes represents 2 river widths of travel. Those 38 minutes represent 2 widths of travel. So 1 width takes 19 minutes, that's the time from start to the first meeting. 8:30 minus 19 minutes gives us 8:11 a.m. That's when the ferries started their journey. Let's recap what we learned today. First, average speed equals total distance divided by total time. Second, watch out for the average speed trap when dealing with different speeds. And third, always break complex problems into simple, manageable steps. Keep practicing, and I'll see you in the next video.